Welcome. In this video, I am going to solve NEET 2024 question in physical chemistry under the topic of some basic concepts in chemistry. Let's see the questions. The very first question is the amount of glucose required to prepare 250 ml of M by 20 aqueous solution is. Molar mass of glucose is given. Then how to approach this question? This is so easy. They are asking the amount of glucose. There is a one formula because this is in molarity, right? There is a one formula. So molarity equal to given weight divided by molecular weight multiplied by 1000 divided by the volume, which is mean by 250 ml. We are going to prepare in SMF, standard measuring flask. It can be 100 ml SMF, 250 ml SMF, 500 ml SMF, anything. That value should be substituted in this place. 100 divided by, simply it is called 100 divided by SMF, standard measuring flask, or else any measuring flask, anything. Can be anything. Here it is mentioned as 250, so I am taking as a 250. This is a general formula. From this formula we can solve this easily. We put 250, then what is the given weight? We don't know the given weight. We don't know the given weight, but we know the molecular weight. Molecular weight is 180. So I am substitute molecular weight by 180. 180. Then if we prepare it for 1 molar, just take for example, because they are asking M by 20, I am just to take 1 M, then I convert this 1 M into M by 20. Okay, this is a way to solve this question. Right. For 1 molar, what is the answer? Let's solve this. 250, which means 1000 divided by 250, it will give 4. Okay, here it is a answer is 4. Then 180 goes here, then 4 goes here. It will give the given weight. Simply said 180 goes in numerator, 4 goes down, which is equal to given weight. This is a given weight of the substance. 180 divided by 4, it will give 45. Okay. The final conclusion is, okay, I am erasing this. The final conclusion is to prepare 1 molar glucose solution in 250 ml. 1 molar glucose solution in 250 ml requires 45 gram. Just like we are going to solve this. M by 20 in separately we can write this like this. 1 by 20 into M. 1 by 20. Okay, 1 by 20. Then what is the value of 1 by 20 is nothing but 0.05. 0.05. So 0.05 molar, because these are same. 0.05 molar. Okay. Then 0.05 molar. 0.05 molar, which is equal to, I don't know the how many weight, which means a given weight. I am taking it as a x. I know the molecular weight is 180. Here the same 1000 divided by 250, which is nothing but 4. 0.05 multiplied by 180, then divided by 4. 0.05 multiplied by 180 divided by 4. It will give 2.25 grams. If we solve this from by calculator, you will get the answer 2.25 grams. This is a way to find the amount of glucose. Here the x is given weight, the amount of glucose is also given weight. We take glucose in particular amount to prepare 0.05 molar glucose solution. This is a general method. This is, we can see in the volumetric titration like this. Okay. This is the next question. 1 gram of H2 has same number of molecules I already told the formula to find number of molecules. Okay, the number of molecules which is equal to moles into just Avogadro number. Avogadro number is we know the Avogadro number. We need to find only number of which means in moles. We need to find how many moles is there. Okay, same as, so we need to find moles of the question, then we are going to find the moles of these four options. Okay, how many moles present in 1 gram of H2? Mole is nothing but weight divided by molecular weight. This is nothing but moles. Weight is 1 gram. Molecular weight of H2, for 1 hydrogen mass is 1. For 2 hydrogen mass 1 into 2, the mass is 2. Okay, then 1 by 2. The number of moles is nothing but 1 by 2. Here m is 1 by 2. Okay, so in finalized form, how can we write this? Just a minute. Okay, because the space is limited here, so I'm erasing every time. For question, number of moles is nothing but 1 by 2 Avogadro number, or else 0.5 Na. This is the number of molecules in the question. Likewise, we are going to solve for the four options given. For 14 gram of nitrogen, it is also same. 14 gram of nitrogen, what moles is nothing but weight divided by molecular weight. For 1 nitrogen, the mass is 14. For 2 nitrogen, 28. If we cut 1 by 2 Na, okay, which is also 0.5 Na. This is a multiple choice question, so only one answer. Okay, option A is right. We can do also for water, carbon monoxide, then nitrogen, but the remaining three won't give the same 0.5 Na. You can try it yourself. Okay, option A gives exactly the same value. The only one formula is number of moles multiplied by Avogadro number. This is the formula to find number of moles. I already discussed in previous two videos. Kindly watch that. This is the third question. On complete combustion of 0.3 gram of organic compound gave 0.2 gram of carbon dioxide and 0.1 gram of H2O. The percentage composition of carbon and hydrogen in the compound, in the organic compound respectively. This is an organic compound. This is a one twist in here. Okay, they didn't give organic compound. They gave just compound. We should take this as a organic compound. Let's solve this. Okay, very first, 0.2 gram of carbon dioxide contain how many carbon? Then 0.1 gram of water contain how many hydrogen? This is our first case. Then we can solve the percentage composition. How to solve this? Then how can we know? This is one of the simplest method. Okay, for carbon dioxide. Okay, just to take 1 mole carbon dioxide contain 44 gram of, which means 1 mole contain 44 gram, because carbon is 12 in gram, oxygen is 16 in gram. There is 2 oxygen, so 2 into 16, collectively it is 30 to 12, which gives 44. Okay, 44 grams. Just like 1 mole carbon dioxide contain 44 grams. In 44 gram there is 12 carbon plus remaining 32 is oxygen. This is oxygen, this is carbon. Okay. In 0.2 gram we only need to find carbon alone. Don't worry about, which means don't take oxygen, only take carbon. 44 gram contain 12 carbon. Yep. Then 0.2 gram contain how much carbon? X carbon. We only need to solve this. The remaining things, that are no needed. Okay, this is only needed. 44 grams contain 12 gram, then 0.2 gram contain how many carbons? How many gram of carbon? Because in we can convert grams into percentage, not moles into percentage. Okay, we don't worry about moles, we don't worry about oxygen, only worry about this. Okay, if we solve this, okay, let me erase this. Okay, this is hereafter it is a simple mathematics. Simple mathematics. Okay, right. 44, which is equal to 12. 44 gram, 12 gram of carbon, then 0.2 gram x gram of carbon. We are going to solve x goes here, then 44 goes here, 0.2 goes here, then 12 multiplied by 0.4 divided by 44. Okay, this is a amount gram of carbon present in 0.2 gram of the carbon dioxide. This is the simplest method to solve this. Okay, then if we solve this, we will get 0.0545. 0.0545 gram. Okay, I'm writing here 0.0545 gram of carbon present in 0.2 gram of carbon dioxide. Likewise, we are going to solve for 0.1 gram of water. Okay. Okay. Likewise, then the other is also very simple. In 0. Which means 18 gram of water contain, there is 2 hydrogen and 1 oxygen. For mass of hydrogen is 1, so there is in 18 2 is hydrogen, 16 is oxygen, acceptable. Okay, right. Okay, we are going to find only hydrogen. 18 gram of water contain 2 gram of hydrogen, 2 gram of hydrogen. Okay. Then 0.1 gram contain what? X gram of hydrogen. Okay. Then x goes here, 18 goes here, then 0.1 goes there. 2 into 0.1 divided by 18. This gives what? If we solve 2 into 0.1 divided by 18, it will give nearly 0.0111, which means 0.0111 gram. This is a final conclusion. We find the gram of carbon present in 0.2 gram of carbon dioxide and gram of hydrogen in 0.1 gram of water. Let's convert this into percentage. Then if we want to convert this into percentage, then there is only one formula: lower weight divided by higher weight, which means this is simple. 0.0545, this is for carbon. Okay, 0.111 divided by, this is for oxygen. Okay, in denominator which will come, there is a one twist. Denominator which will come, in denominator there will be 0.2 is there, 0.1 is there, and 0.3 is there. Which will come in the denominator? Okay, because I already said there is a twist. The percentage composition of carbon and hydrogen in the compound means organic compound, they they want the answer, which means they want the percentage composition of carbon and hydrogen in this organic compound, not in a 0.2 gram, not in a 0.1 gram. There is a twist. Okay, the organic compound contain, or else on conversion, 0.3 gram organic compound converted into 0.2 gram of carbon dioxide and 0.1 gram of water. There is no loss of mass of the organic compound. Okay, we need to find the percentage composition of carbon and hydrogen in the organic compound alone. So in the denominator there will be 0.3 will come. 0.3 will come. Okay. If we solve the percentage of carbon and hydrogen, then it multiplied by 100, because we need to convert it into percentage, right? Percentage. So multiplied by 100, multiplied by 100, multiplied by 100, it will give the answer. Okay, the answer is nearly for a carbon it is 18.18 percentage. For oxygen it is 3 point, sorry, for hydrogen, okay, hydrogen is 0 3.7 percentage. Then this is the answer. Option B is the answer. Then this is answer. This is the simplest way to find the answer. This is not hardest way. Okay, this is simplest way. Next, this is on another simplest question. These are the basic concepts. Okay, 1 gram of sodium hydroxide was treated with 25 ml of 0.75 molar HCl solution. The mass of the sodium hydroxide left unreacted is equal to, which means 1 gram of sodium hydroxide react with 25 ml of 0.75 molar of solution. We should take in a common unit manner. I mean 1 gram of sodium hydroxide react with how many gram of HCl, or else 1 mole of sodium hydroxide react with how many mole of HCl. We should take in a common unit so that we can find the unreacted form of sodium hydroxide. We can convert the two things into moles very easily. Okay, 1 mole of NaOH contains 40 grams. I take only NaOH. Okay, NaOH. For sodium it is 23, oxygen it is 16, hydrogen is 1. If we add it will give 40. Then 0.1 mole contain 4 grams. Okay, 0.1 mole contain 4 grams. If we take 1 gram, which means divided by 4, here it is also divided by 4. 0.1 divided by 4, 0.1 divided by 4, it will give 0.025. Then 0.025 moles, 0.025 moles present in 1 gram of sodium hydroxide. Okay, we convert into moles. Then we need to convert HCl into moles. How to convert this? It is also so simple. Okay, molar, it is just a unit conversion. Okay, see clearly, molar is nothing but moles per liter. Okay, moles per liter. Okay, it is 25 milliliter. Okay, 25 milliliter I converted into liter, which means 25 into 10 to the power minus 3, or else 0. If it is 10 to the power minus 1, 2.5, 10 to the power minus 2, 0.25, 10 to the power minus 3, 0.025 liter. They gave molar, which means mole per liter is there, then liter is there. If we multiply mole per liter into liter, we will get the answer in mole. Acceptable? Yeah. Okay. Mole per liter multiplied by liter, it will give mole. Then 75 molar, which means 0.75 molar. Then 0.75 mole per liter multiplied by 0.025 liter, it will give moles. Simple unit conversion. Okay, these are all the basic unit conversion. If so, I am going to multiply those two. Simple. How to multiply this? Those is so simple. Then 0.025 liter multiplied by 0.75 mole per liter. Then I will get the value in moles. Okay, 0.75 multiplied by 0.25. Then what is the value? The value is nothing but 0.01875, something 0.01875. 1875. These are all the moles. Okay, this much of moles react with the previously we find moles of NaOH, which is nothing but 0.025 moles of NaOH. NaOH and HCl's are univalent because there is one OH minus in NaOH and one H plus in the HCl. Okay, one OH minus react with one HCl to neutralize each other. Okay, then 0.1875 moles of HCl react with 0.025 moles of sodium hydroxide. So if we subtract these, we will find the remaining in sodium hydroxide. The amount of sodium hydroxide is largest because that is 0.02. Here it is 0.01. If we subtract these two, we will get 0.00625 moles. 625 moles. They are asking the answer in gram, which means milligram. First of all, we need to convert into grams. How to convert into grams? Moles into grams. It is nothing but multiplied by molecular weight. Molecular weight is 40 gram per mole. Molecular weight unit is gram per mole. Then per mole get cancelled. Then 40 gram multiplied by 0.0625. Okay, 40 multiplied by 0.0625 is nothing but 0.25 grams. Then 0.25 grams into milligram multiplied by 1000, you will get 250 milligram. Then 250 milligram is the answer. In this question, the unit conversion is a key to solve this. Okay, only unit conversion plays roles in this question, not a chemistry. Okay, in unit conversion manner, we can solve this easily. Then the highest number of helium atom is in. I am also solved this in the previous two videos. We need to find the number of atoms. Number of atoms. Number of atoms, the formula is nothing but moles into atoms per molecule or atomicity into Avogadro number. The highest number of helium atom. In the first case, there is 4 moles. 4 into helium is only 1. 4 moles of helium, which means there is only 1 helium, so atomicity is 1 into Avogadro number, which gives 4 Na. Okay, in the first option. Then second option, 4U. U means there is a weight for atomic unit, or else unit, or else gram. Okay, everything is same. Okay, then 4 gram of helium. One helium has 4 grams because the mass is 4. So it clearly indicates 4U of helium, which means there is only one helium. So number of moles of helium is 1. So there is 1 into Na, which gives just Na. Here it is Na. Then these two options are same because here it is also 4 grams. These two options are same. Here it is also Na. Here only is a 4 Na. These two are Na. Then what about the last option? In last option, we need to find the number of moles. Number of moles is very simple in the fourth option because they have STP. STP means standard temperature pressure. At standard temperature pressure, every gas, which means every ideal gas, occupies 22.4 liters. In this case of helium, it will only occupies 2.27. So what is a mole? Number of moles is nothing but 2.271098 divided by 22.4. It will give 0.01. Then 0.01 moles. 0.01 moles multiplied by 1 multiplied by Avogadro number, it will give 0.1 moles. It is approximately 0.01. Okay, it is not accurate. Approximately 0.01, near whole number. Okay, which means near a decimal whole number. Okay. 0.01 moles. So 4 moles of helium contain highest number of helium atom, which means 4 into Avogadro numbers. So option A is the answer. Okay. This is a final question. This is very interesting question. Okay. The compound X contains 32 percentage of A, 20 percentage of B, and the remaining percentage of C. Then the empirical formula of X. They didn't give the percentage of C. We need to find the percentage of C, and we can write the empirical formula. That's it. Okay, clean and clear. Clean and clear. Okay. And they have hint as a atomic mass. It is nothing but the compound X contains 32 percentage of A, which means 32 percentage is nothing but a weight. Okay, weight is nothing but a given weight. Okay, then 32 divided by 64, because 64 is a atomic mass of A. Then 20, 20 for B, 40 is atomic weight of B. And we don't know for C, so take it as a X divided by 32. If we solve this, 1 divided by 2, then so 1 divided by 2, then what about X? Simply thinking, here it is 32, here it is 20. If we add 32 plus 20 is 52 percentage. Okay, total percentage is 100. 52 percentage, there is a and X. Then remaining 48 percentage will be C. Remaining 48 percentage will be C. So if we put 48 here, it is nothing but 3 by 2. If we take LCM, if we take LCM multiplied by 2 on both the sides, we will get 1, we will get 1, then we will get 3. This is the empirical formula. Because 1 into 1, 1 is to 1 is to 3. Then A is 1, sorry, here it is a ratio. Then A is 1, B is 1, C is 3. This is the way to solve this question. Take the percentage as a weight and it is divided by the atomic weight or molecular weight. We will get the in fraction. In this case it will be a fraction. Then fraction we can convert that fraction into whole number by LCM method. Simple. The only problem is remaining percentage. Remaining percentage is nothing but add these two, then minus from 100 percentage, we will get the remaining percentage. This is very simple and interesting question.